I'm finally actually working on my dream game, Themengi, a Xenolinguistics adventure game, using Rust in the Bevy engine. At work, I'm a programmer and a computational linguist. But on the side, I've been working on a linguistics game. Themengi is a game about learning a language, an alien language. It's a conlang, or constructed language, that I'm creating as part of making the game. Figuring out how the language works is the main puzzle of the game, and the player will use it to navigate through the world, a bit like a terminal or a text adventure. That's the theory, anyways. I spent the last few weeks working on a basic skeleton for the game. I actually made the first prototype way back in 2018 for the second Game Maker's Toolkit Jam, where the theme was genre without mechanic. It didn't fit the theme very well, but it did get number 46 in design, so hey. But I wrote it in 48 hours using jQuery, so the code is not good. And it was basically an ugly website. So I'm starting from scratch here. The goal is to make something that looks good and feels like a game. I'm not using Unity or Godot for this game, though I did make little prototypes in each of those engines just to play and see if they'd be feasible. The main reason is I need to integrate with an open source library written in Rust, so I'm forced to use Rust. Unfortunately. Okay. It's my open source library, and I chose to write it in Rust. It's my fault. But I like Rust, so if you think about it, it's really Rust's fault. The library is called TreeBender, and you can go look at it on GitHub if you want. Link is in the description. But basically it's a parser. A parser, you say? Why did you need to write that? There's parsers everywhere, in every language. They parse JSON and C# and JavaScript and... Well, this isn't just any parser. It's a special parser. A head-driven phrase structure grammar symbolic linguistic parser, to be precise. Without going into too much detail, head-driven phrase structure grammar is a way to parse and analyze natural languages. Computer parsers are everywhere, but they're built to handle artificial languages. Nicely behaved, well-engineered, neat languages like JSON, C#, or theoretically speaking, JavaScript. Natural languages aren't like that, to put things mildly. Basically, I needed something custom, and that project spiraled out of control a bit and became TreeBender. But now I have it, and it only took 3 months. And it's really fast. Or at least fast enough. I can use it to give Themengi all kinds of wonderful natural language complexity that would totally spin the head of a weak baby LL1 parser. But enough about parsers. Let's get back to the good stuff, game development. So I have this library using Rust. I could theoretically integrate a Rust module into a Unity or Godot game, but it's kind of a pain. You have to link a native module or rebuild the Godot editor with a build time module thingy and CMake and make files, and it's just a huge pain. So when I found this cool new game engine called Bevy, which is also written in Rust, it seemed like a perfect opportunity to use some brand new alpha release software to build my dream project. Kidding aside, I actually really like Bevy. It's still unstable, but it's also totally open source, so I can just read the source code for the engine when the docs aren't written yet. And since it's written in Rust, and so is my game, there's basically no boundary between the engine and my game, which is really cool. I've actually pulled the Bevy code into my game's project tree, so I can just drop print statements in the engine code or straight up modify any part of it to fit my game perfectly. And it's small and simple enough that my puny brain getting a handle on how the whole thing works is actually feasible. I don't think anyone on Earth has actually read all of Unity's code. It's probably not possible, unless you're like a robot or John Carmack. So the first thing I decided to write was probably the most tricky, which was the upscaler. I want this game to be pixely, and that means it needs to be crisp. This? Ugh, trash. But it's really easy to have this happen when you're rendering pixel art on a modern display, since each art pixel corresponds to 100 pixels on the screen, unless you're playing the game on your Samsung Smart Fridge or Nokia brick phone. Modern GPUs try to be nice and helpful, and they smear the pixels all over the screen for you, trying to make things look smooth. You can try to avoid this by smashing minfilter equals nearest everywhere and rounding the crap out of all your coordinates, but it's really tricky to keep everything aligned to the pixel grid. Luckily, there's a nice trick. You can render to a fake low-resolution screen, an off-screen texture, scale that texture, being very careful during the scaling to not blur anything, and then render that upscale texture. As long as you're careful the one time you need to scale something, everything else is pixel perfect for free, because there's no off-grid pixels. Every pixel on the texture is naturally aligned to the grid. This technique is called a bunch of different things depending on the details of it, but I decided to call it upscaling since that makes sense to me. This technique is theoretically pretty simple, but it was a bit tricky to get working in Bevy. This isn't really the Bevy team's fault. The current renderer in Bevy is temporary and due to be replaced anyways, but for the moment, the way everything is set up in there makes it really difficult to replace pieces of the renderer without ripping everything out. But I couldn't rip everything out because I need the old everything to render anything that's not upscaled, namely the upscaled texture after I'm done upscaling. So I had to do a weird kind of dance. First, I had to kill the existing render plugin and slot my own in its place, but then have my own plugin build the old render plugin with custom settings, like a parasite puppeteering someone like a skin suit. Then, instead of acting like the original render, which only adds one render pass, I add two render passes. Each render pass will target a different set of objects. The low-res pass will target all the game objects and render them to the low-resolution texture. Then, the high-res pass will render everything else at native resolution, including the texture that results from the low-res pass. Confusingly, the low-res pass will render all the entities tagged with the component main pass, but the high-res pass attaches to the node that's labeled main pass. This is just to get everything working right. Then I spawn two cameras, one for the low-res pass and one for the high-res pass, and the entity that will render the upscaled texture. Yeah, there's a lot of steps here and it took me a little bit to get my head around, but it works. With the pipeline done, I started working on a custom sprite type to implement object highlighting. I want this to feel like an old school point and click game, so I want objects to have a nice chunky pixel outline when you hover over them. But I don't want to make that outline, are you crazy? That would take like 2 extra minutes per sprite. Come on, I'm going to do it with a shader. Time to figure out how shaders work in Bevy. That took like 2 days. Debugging GPU code is very hard. If you make a mistake, it doesn't like print an error or fail to compile. It just doesn't render anything. I ended up adding some code inside the engine to log when certain GPU bindings weren't being set, which eventually helped me track down the problem. The problem is basically that the thing I needed to pass to the shader, which is this highlightable struct, I didn't have that little shader def line. Yeah. That line tells Bevy to generate a define in the shader to indicate that the entity has this highlightable component. Without it, I was trying to unconditionally bind the uniform, even if the entity didn't have the component, when I needed to do this instead. And then it worked. Well, there was another incident involving a typo, but we don't talk about that one. And hey, look! I can hover over the sprite and it dynamically generates the outline. Saved me so much work. Imagine how long clicking all those pixels in a sprite would have taken. Way longer than 2 days, definitely. Very satisfying to see it working, though. Then I had to do this all over again to support sprite sheets. Luckily, it only took 1 day this time, since I could reuse most of my other work. And that's it for this devlog. Next time I'm going to talk about some other stuff, like fonts. Who knows? Not me. Thanks for watching.